Hi, I'm Jeff Franke, Editorial Director of Manufacturing.net and Manufacturing Business Technology. Welcome to Security Breach. I'm always tempted to start out each episode by talking about a problem, and then setting up our guest as a solution to that problem. It's formulaic and a bit redundant, but it's also very effective. So I'll apologize in advance because I'm about to do that very thing again. The difference is that Howard Grimes, the CEO of the Cybersecurity Manufacturing Innovation Institute, or CyManII, is looking to help provide a lot of solutions for manufacturers. The DOE-funded institute, which is also supported by a number of private sector partners, is based out of San Antonio and has made a tremendous amount of progress as it works to sever some of those government ties while assisting the industrial sector with ever-changing cybersecurity challenges. As we discuss workforce deficiencies, secure by design, an evolving threat landscape, and the ongoing struggles with legacy OT infrastructure, I'll challenge you to find something that the institute couldn't help you and your organization jumpstart, solve, or streamline. With that in mind, it's my pleasure to welcome Howard Grimes to Security Breach. Howard, thanks so much for joining us today, and welcome to Security Breach.
Thank you for having me.
Awesome. Hey, let's get going here. Usually I wait for a little bit into the interview to talk about this, but I think it makes sense to start right off in front. Tell us a little bit about the Cybersecurity Manufacturing Innovation Institute. That's something that maybe not a lot of us are as familiar with as we should be.
Right. So the U.S. Congress funds 18, it's now 18 Manufacturing USA Innovation Institutes across the United States. Each of these institutes is expected to have a national vision and a national impact. So even though we're regionally based or we're housed, if you will, at a particular location, we're expected to have that national impact. The act that funded these institutes is called the RAMI Act, the Revitalizing American Manufacturing Initiative, and it's almost 10 years old. So of these 18 institutes, CyManII, or the Cybersecurity Manufacturing Innovation Institute, is one of those institutes, and we happen to be funded through the Department of Energy by, again, the money that flows out of the RAMI Act through the U.S. Congress. So the other institutes are funded either by the Department of Energy, by Department of Defense, or by the Department of Commerce. The most recent one, and the one that everybody notices today, is the Semiconductor Smart USA Institute that was birthed, if you will, out of the CHIPS Act, and it's housed within the Department of Commerce. CyManII, is focused entirely on cybersecurity for manufacturing. So when the competition opened up, the Department of Energy understood at a very deep level that existing technologies for cybersecurity were simply not effective, absolutely necessary. Totally not sufficient is the way I often describe it. If you look at any graph or any data on the volume of cybersecurity attacks against manufacturers, or anybody but manufacturers for this conversation, if you look at the successful implementation of those attacks versus failure, any metric that you choose to look at, you will find that all of manufacturing is subjected to an highly increasing, almost exponential increase in the number of cyber attacks. The efficacy of those attacks is similarly growing. The veracity of those attacks is growing, et cetera, et cetera. So if existing technologies worked and were not only necessary but sufficient, that's not what we would see. What we would see is either a flat line or, a decline in the successful cyber attacks. But the opposite is true. And DOE, Department of Energy, understood that. And they understood that really going back and having a fundamental understanding, and this is where I tend to geek out a little bit, but having a fundamental understanding of the physics of cybersecurity and the fact that those physics change on a day-to-day basis. We're now talking about AI. We're talking about quantum. These are things that nobody talked about a decade ago. So the physics of our systems is changing, and DOE understood and recognized that. Also, to get at those physics, as any of us that went, through some sort of an educational system understand that physics rapidly evolves into underlying mathematical principles. So we are, as an institute, we are focused on understanding the physics of cybersecurity and understanding the underlying mathematical foundations of those physics in order to develop, implement, and deploy for industry next generation cyber innovations that are not only necessary but also sufficient. So we are a public-private partnership. We have the best-in-class research universities across the United States. We have best-in-class DOE national laboratories in advanced manufacturing and cybersecurity. And we also have, the leading OEMs in advanced manufacturing on the team. We are housed, in San Antonio, Texas. But we have a distributed, I always talk about us as a hyper distributed organization. So we have, about 25 staff, in San Antonio. We have a demonstration facility there. We call it the Cybersecurity for Manufacturing Center, C4M. But we also have, close to 300 part-time FTEs across the nation that all work on this public-private partnership to develop, these next generation cyber innovations to cyber secure or secure our manufacturing enterprises, including the supply chains.
Yeah, so that's a lot. And I would argue, this really goes back more than, or not even a decade, really. I think 2020 is really when the light bulb went on for a lot of manufacturers due to COVID and more remote working and things like that. So when it comes to really working with manufacturers, where do you start? I know you guys do a lot with ICS. I know you get into supply chains, but what typically is the jumping off point?
Well, we have several, as you might imagine. With a team of that size, we're really focused on, our technical focus is, I would characterize it as focused around three distinct areas. First area that we're focused on is developing secure by design architectures. These are wrap systems for both legacy and greenfield manufacturing enterprises, but they take the current understanding of secure by design to a whole different level. We have a very holistic, mathematically underpinned, integrated approach to developing these secure by design architectures. Our goal is so that these architectures are secure by default, and your systems that we implement those SDAs onto are secure by default. So our bar is very high. Part of our mathematical focus is on the modeling and simulation of cyber attacks in virtual space. So we feel it is absolutely imperative that we begin to quantify the impact of these cybersecurity changes. So if I go to a company and I say, I have these three elements of secure defensible architectures that you need to implement, I need to be able to have the talk with their leadership as to the quantified outcome of those adjustments or fortifications. So secure by design architectures is really one of our design elements that we're focused on. Part of that, but separate from in some ways, is what we umbrella term or use an umbrella term to cover it. We call it those cyber physical passports. So devising identity centric cyber physical passports whereby every operation in a supply chain that feeds into a company for a manufacturing process, we can verify that every part, every component is both born qualified and the entire supply chain is rooted in trust via the implementation of these CPPs. And we have 5 patent pendings around that technology now. We're very careful into what we patent versus don't patent because the minute you patent it, it's a public record, and our adversaries get to read all about it. So we're extremely cautious in how we've gone about managing our own intellectual property, but nevertheless, we have five patents pending. The third element that we're really focused on is what we call cyber weakness enumeration. So the world of cybersecurity today, chases what are known as cyber vulnerabilities. So, somebody defines or discovers a cyber vulnerability in your code. The origin or owner of that code will patch the code to, take that vulnerability away. And, we all know what Patch Tuesday is, right? So every Tuesday, multiple companies across the world will say, update your software system. We found, it's 100 more vulnerabilities. Again, any graphical examination or data examination of that process, the number of vulnerabilities is growing exponentially. And a lot of that's because our ability to find those vulnerabilities is also getting better. So the bottom line, though, is it's not a scalable approach. And we understood that, and we have developed an entirely new approach along with some of our partners. We call the cyber weakness enumerations, where each CWE or weakness, if you will, captures thousands to tens of thousands of vulnerabilities. So by addressing the fundamental weakness, which is often at the mathematical level, you can patch or mitigate thousands and thousands of mitigations as we do so. So those are, I think, the 3 technical thrusts that the Institute is focused on. The additional thrust is workforce development. And we have a commitment to upskill and reskill an alarmingly high number of 1 million people in cybersecurity. And there's really 2 reasons for that. If you look at the current situation in U.S. manufacturing, over 80% of successful attacks are because of or can be traced back to the human in the loop. So that's bad in the sense that 80% of the failure is the human in the loop. The good is that if you properly train and educate that workforce, you have an 80, you can stop an amazing number of these cyber attacks. So it's bad news, but good news. So we have major programs, focused on upskilling and reskilling the incumbent workforce so that they're more aware and more able to cyber protect their manufacturing processes. The second reason we're so dedicated towards workforce development, though, goes back to the 3 technical innovations I just talked about. So you can roll the clock forward a few years, and you can imagine Howard, going into, a company and talking about a secure by design architecture, a cyber physical passport, how we need to convert you to CWE detection and mitigation as opposed to what you do now. My guess is that I would be very quickly shown the exit door and moved on out of their systems. And the reason for that is there's no trust equity built between Howard and whatever that company is. But if we've been there for 2 years and we've delivered, proven, capable, problem-solving workforce development, there is that trust equity that then exists, and we're going to be more open to, a more serious discussion around technical innovation. So I hope I answered your question. If I didn't, please follow through.
No, absolutely. Good overview in terms of the priorities of the organization and everything else. The one thing I'm curious about is when you're having these conversations with manufacturers, is there a typical mold that they fall into in terms of size or scope or what their focus is from a production output, or is it across the board?
I'd say it's across the board. The things that we notice the most when we do our assessments, if you will, is, and it's sobering, but the lack of preparedness, is quite apparent. Major OEMs typically have the resources and the expertise, the workforce, if you will, the technical expertise they need to take full advantage of all and every, existing cybersecurity tool at their disposal. And they do a pretty good job of that. That doesn't mean they're immune, because those tools are necessary, but they're not sufficient. It's just that simple. Smaller manufacturers face the other problem, right? They are often running legacy systems. Sometimes some of those software systems haven't even been updated in quite some time, right? And they're focused on production, meeting their production criteria. So we see it all. We have gone in, I won't say the company's name, but I will tell you there's a medium-sized additive manufacturing company that was attacked by ransomware successfully. They paid the ransom. They recovered, as is typical, part of their data, not all, which is again very typical. They then went and invested immensely, in existing technology so that it wouldn't happen again. And it happened again. And the second time that the breaches were more sophisticated, more impactful, and that's when they found us. And we went in, and using the CWE approach that I've just outlined, we've identified about 1,100 CWEs. And this particular company, after all the cyber fortifications that they'd invested in, were almost at 1,000. So, the gap there between necessary and sufficient is pretty darn large, and that's kind of one of the soapboxes I get on all too frequently, frankly. But so we see it all. We see in the small and medium-sized manufacturers and it's even changing now, Jeff. I mean, 5 years ago, I'd say the bottom line strategy was ostrich, right? Stick our heads in the sand and hope
Yeah.
nobody finds us.
Yeah.
Or this mythology that, well, we're too small.
Yeah.
We're not going to be on their radar or target. Well, that's all changing, and it will continue to change. And so everybody is now taking these issues more seriously, and that's good because everybody's trying to figure out how to upskill their workforce, what sort of cyber fortifications they need to take. They're paying a little bit more attention to the NIST certification standards. If they're in the defense industrial base, the CMMC requirements. And again, all of that absolutely necessary. And, I'm all on board for people doing that. So we see the terrain, if you will, improving, but we also see the attack vectors becoming a lot more sophisticated and voluminous. We see both. We see people trying to catch up successfully, but we see the attack vectors, continue to morph and evolve. And that's again why we go back to the fundamental physics of those systems, because it's only by looking at the physics of that cybersecurity you're really going to be able to do that.
It's really encouraging to hear that we're seeing more small and medium-sized manufacturers get more involved in cybersecurity and working with organizations such as yours. My theory is we see a lot of this reporting on different types of attacks, especially ransomware, and we see some of the numbers. Yes, they creep up, but then they stagnate. Maybe some months they even go down. I think that's because a lot of these small and medium-sized industrial firms are getting hit, but they don't really say anything about it. They don't report it. They pay the ransom and they move on. What advice or what's your take in terms of how some of the larger enterprises maybe can put some pressure on some of these small and medium-sized manufacturers that are part of their supply chain that are impacted just as much when they get hit to really start putting more resources towards cybersecurity. And like you said, especially on the OT side, the IT stuff, that makes sense to them. The OT stuff is still very complex.
Right. Very, very complicated. And Jeff, I love that question. So let me do my best to unpack it in a smaller amount of words, because it's one of my buttons that you don't want to hit too often. But I think I believe that the way to really impact cybersecurity posture across the United States and across the manufacturing enterprise in the United States is, frankly, to use our OEMs and their supply chains, their tier 2 and tier 3 suppliers, and begin to think of that as an integrated system. And when I talked earlier about our cyber physical passports and our secure defensible architectures, our holistic framework does just that. We see every operation, every action that a machine takes, every button a human being pushes as a node that we capture inside of that bigger physics picture of the manufacturing process. So we capture every transaction, every energy transaction, every physical transaction, and we capture it in what we call the cyber plane. And we add to that cyber plane the energy coefficients. Again, I'm leaving the math out of this. But we capture those energy transactions. And you might ask, well, why do we do that? Well, we do it for twofold. First reason we do it is for a CEO to invest in cybersecurity, they're going to ask the question, what's the return on investment?
Yep.
And usually the poor CISO is saying, well, we're helping things never happen, right? It's an unquantifiable argument by definition. And what our energy ROI perspective says is, if you fortify with these elements of secure defensible architectures, it's going to decrease our energy cost by X, and it's going to increase your productivity by Y. That's something a CEO can kind of get their heads wrapped around and start to make those strategic investments. So that's why we are focused in the way that we are on not just the cyber hardening, but also in the quantification of that hardening and understanding, again, the physics and the mathematics of the impacts of those technological changes. So we see that, again, that integrated connections between those as a way to do that. The second element, in that is back to workforce development. Again, the major OEMs, most that I talk to, they have some pretty good, solid in-house training programs for their own people. There's a sharp line, a drop-off line, though, to their tier 2 and tier 3. And so we're working with several OEMs right now to offer for them for very low cost, if we, even free to get people started. But how can we upskill your workforce at your tier 2 and tier 3 suppliers? Chances are, greater than 99%, those suppliers are small and mediums. And so that is, I think, the best pathway out there. You can debate this, and trust me, people do debate it, even, between myself and the Department of Energy and Manufacturing USA, et cetera. You can count a lot of small and mediums and say, look, we have 300 SMMs. That's awesome. But we have over 100,000 total. Yeah. I think the math of how you get there is through the OEMs. So anyway.
No, I agree 100%. I think it's also encouraging and refreshing to hear this much conversation about the workforce and workforce development and training, and really taking that seriously, because in a lot of organizations, it's sort of a check the box type of thing. Hey, let's do the refresher. Don't click on the links. Let's make sure we don't get a phishing campaign caught up in here, all that kind of stuff. But you're right. Putting more focus on that goes a long way. So does sort of the culture that you can embed within your organization. So it's not about shaming and blaming people who do click on that link or do something wrong, but using it as a teaching moment. What are some of the things that you've either experienced or tried to encourage the folks that you're working with to embed this culture of it's not about blame, it's about teaching and learning and making sure everybody feels comfortable raising their hand when they do screw up?
I think we do it by doing exactly what you just said. We talk about it like that. This is not about finding the poor human in the loop that, accidentally clicked on a phishing thing.
Yeah.
And that screwed your company up. So you better go fire that person. And, if you're that person, you'd better never tell anybody. Maybe it was me. We can all learn from these things. And, we've encapsulated a lot of that training, into our curriculum so that when we go into companies, it's very much a, as you said, blameless or anonymous, set of exercises. We're not there to make any individual, account feel to be blamed for this. We're there to train up the entire organization to a higher level of standard.
Howard, I want to circle back to something we've talked about earlier and is a big part of what you guys do, and that's secure by design. Right now, one of the biggest challenges in the industrial sector and specifically manufacturing with all this great IoT technology coming in is we're connecting new stuff to legacy stuff. And that connection point becomes a real issue because the manufacturer feels like the supplier should be covering them. The supplier is feeling that the manufacturer should be taking care of it. How do you bridge that gap a little bit? And I know that conversation is getting better, but how do you help it evolve to a point where we make sure we're both covering all our bases?
Yeah, that's a very tough challenge, right?
Yeah.
I think there's a couple elements and probably more than a couple that we could start to talk about. The first element, if you will, is cost versus productivity. If you can change that equation, you change the whole discussion, right? If the person with the legacy system is now understanding that, by doing these cyber fortifications, that's going to save me my energy bottom line, it's going to increase my productivity, it changes the dynamic of their thought process instantly. And we've been able to show that, by the way. We've gone into I mentioned earlier that we're, a big part of our base is in San Antonio. Well, we've been able to go into I would call it a medium manufacturer. It's a supplier, in the oil and gas industry, but it is a refiner. And we've been able to go in and look at some of their processes, not look at, we examine in great detail their processes. And we've been able to show them, some of their most visible, if you will, attack surfaces. And we've been able to shore those up with secure defensible architectures. And at the same time, we've been able to demonstrate for them that we lowered their energy costs by over 12%. So that's a big deal for them. That's their bottom line. We did it as a pilot study, on a fraction of their processing capabilities, if you will, but we're now back there, doing it again and again because they like what we do. They can see the cyber fortification, but they really can measure that productivity increase and the energy efficiency savings. Again, it just impacts their bottom line. So I think that's one way that you have to do it. The other way is more, abstract, if you will. But we've always visualized cybersecurity. If it's going to be sufficient, it has to be different at a technical level. And we've been talking about that throughout the whole last half hour. But it needs something more, right? It won't really impact manufacturers or manufacturing workers unless it is also pure, P-U-R-E. And we define that as cybersecurity that's pervasive, i.e., it's everywhere. It's unobtrusive. So, the line worker can understand it and make sure it's functioning properly. It doesn't require a college degree in computer science to run the damn thing, you know. It has to be resilient. It has to be, when attacked, it has to be able to get back quickly. So at a manufacturing level, that's decreasing downtime, right? And anytime you talk to anybody in manufacture about a realistic way to decrease your downtime, they want to hear what you're talking about. The fourth element of Pure, the E, is economical. It can't cost more than the savings it produces. And so when we design our secure defensible architectures, when we design our CPPs, when we implement our cyber weakness enumeration approach, we ask ourselves constantly, and I won't describe how we work in great detail, but we do practice a new form of agile scrum development so that we can do things quickly, efficiently, we can fail fast and succeed even quicker. But every time we go through those agile scrum processes, we ask ourselves the pure question every single day. Does it meet these criteria? Because if it doesn't, if it's too complicated and it can't, because of that, it can't be unobtrusive, we got to think of a different way. So we're always, and that's why we practice that agile environment. And by the way, when we do that, I mentioned earlier, it's a bunch of, academics from universities and national labs, but every single one of those Scrum teams is anchored by, private industry. So at the end of the day, they're always asking if it doesn't matter to me, and our response is, then it doesn't matter to us. If it's not industry relevant, we're not interested. Sir, we can do some really cool stuff at mathematics, but if it doesn't apply to industry, we got to figure out a different way.
Yeah. No, I love that PURE acronym. I mean, it makes a ton of sense because to me, what it says is you're getting buy-in at every level of an organization. And really, that's what it takes for cybersecurity to be effective. We've talked about the impact of, the human element, and this just seems to reinforce that dynamic and expand upon it, really. So it makes a lot of sense. One of the things I want to talk to you about, Howard, as well, excuse me, is your approach in seeing, you're exposed to all these and tracking down all these different vulnerabilities. What is your take right now on the attack surface or the threat level, different threats that are out there specifically for the ICS, for the industrial control systems that are really just getting bombarded right now? It started with a lot of hacktivists, if you will, or state-sponsored folks going after utilities, and it's really morphed from there. They've kind of offered a blueprint, if you will. What are you seeing right now? What's sort of lighting up your radar in terms of some of the bigger threats out there for manufacturers?
Well, they're growing.
Yeah.
And they're growing quickly. And, part of why I said, just talked about the agility of these problems and understanding the physics of cybersecurity and how the physics of cybersecurity is changing, because that impinges immediately on, the responses. It impinges immediately on the attack vectors, how they're being utilized. Look, some of the things we all, I think, know about, is AI has arrived, right? Artificial intelligence has arrived. It's here. It's no longer theoretical, or applied, by small numbers of companies, if you will. It's everywhere. And, the tools of AI are growing every day. And so that creates a whole new physics of cybersecurity issues. We have to understand how that impacts the physics of our systems so that we can build fortifications against those challenges. And so, AI is certainly one of them. And let me take it down into a whole different level, because when you ask a question like you ask, most people gravitate up towards sort of the high end of attack vectors. But let's take it to the low end. Let's take it to phishing attacks. How do we train people to avoid phishing attacks now? Look for misspelled words. Look for grammar or syntax that doesn't make sense. Look for odd names, those kind of things. They again, great, it works, right? But now imagine the people generating that phishing attack have just a very small, simple AI. They run it through Chat GPT. Can
Yep.
you clean this up for me?
Yeah.
Well, all the misspellings disappear, all the syntax changes disappear.
Yeah.
You have a much more sophisticated looking attack. They might even ask GPT, can you fix the color scheme for me so it looks uniform? You
Yeah.
know, look, I've played with this myself. It works. Okay.
Mm-hmm.
It doesn't
100%.
take a
Yep.
amount of your time to make it work. So, you can think about the impact of AI on very simple phishing attacks, which are, as our workforce development team is already doing, we're incorporating that, we're adapting to it, we're thinking about how we train for that new type of phishing attack, schmishing attacks, et cetera. How does that impact your ransomware? Yep, it absolutely changes the physics of
Yeah.
cybersecurity for those ransomware attacks. Because now you can query the AI and you can say, hmm, I'm going into this type of a company. It doesn't even have to be a specific company. I'm going into this type of a company. What's the most vulnerable data spots that I need to pay attention to? And the AI is going to tell you, yeah, don't worry about all that. Worry about this. It's their CAD files. Go get their CAD files and they're going to be brought to their knees, right? So we have to really think about those new things. We're already, the scientists and engineers at the institutes are already worrying about or thinking about, the impact of quantum computing, because all of our algorithms that we use to date are based on mathematical principles. Um, and, there's very famous security algorithms out there that we all still use, the RSA algorithm being, the one most everybody knows about. Uh, if, if and when, or say when, quantum gets here, well, quantum encryption goes away. Yeah. So what are you going to replace it with? Because you got to be thinking about that now because it's going to happen. It's just you can debate, is it 10 years out or is it 5? Depends on how much, different companies throw into the resource base of solving some of those technical challenges. So, you've definitely got to think about the landscape and how it's changing. And that's where I think, institutes like CyManII are so critically important because I don't want your audience to start calling you up and saying this guy's a nut job, but I'm pretty familiar with what's going on out there in terms of cyber defense capabilities. And I don't know of anyone other than CyManII that's really thinking hard about this, at this time. I think it's an area that we need to grow and expand because I think the threat vectors, you know, at the sabotage level, at the advanced persistent threat level, absolutely will increase, but also at the hygiene level. There's very simple ways you can, use existing, tools to make those attack vectors bigger, better, stronger. So how are your defenses going to be even bigger, even stronger than those?
Yeah, it's the AI genie is sort of out of the bottle in terms of what it can do and everything else. The quantum stuff, I think, is something more people need to pay greater attention to and put some more resources to. I would agree. I always like to ask this question: people who are in your position, Howard. Not only are you aware of all the things on the high level, the top level, in terms of all the over higher level issues and stuff that we have when it comes to industrial cybersecurity, but then you see a lot of these individual things that can pop up in some of the smaller to medium to larger size enterprises. What is the biggest thing that maybe gives you some peace of mind, some positive outlook in terms of the future for cybersecurity in the industrial sector? Because, man, there's a lot of stuff you could definitely get hung up on and sort of want to take that ostrich approach a little bit. What keeps you positive?
I think it goes back to something I said earlier, and that is that the culture, if you will, is changing. To be honest with you, Jeff, when I was first putting the team together, that today is called CyManII, part of what I had to do was enlist, companies on that team. And, we did that, but it was not an easy lift. And one of the reasons, or some of the reasons it wasn't because of that ostrich approach. Even some of the larger OEMs were like, what we're making just isn't, that's not of interest. We're going to be okay. Well, now they've been attacked and now they know they're not okay. Um, and, overall, getting people to sign on, because 5 years ago, 6 years ago, this discussion was all about the what ifs, but literally, and it's kind of a weird way of looking at it, but every analysis, statistical, graphical analysis of cyber attacks, I'm drawing this to your readership, that's the curve, right? 5 years ago, it was kind of like, bum, 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 but now it's this. And everybody's aware of that. If they haven't been hit, they know a colleague in another company, one of their suppliers, whatever that's been hit. So because of that, everybody is more concerned about this. The federal government is taking it more seriously than ever before. Um, I think you'll see more of that. We can all debate whether, this part of what the federal government approach, is effective or less effective, but, overall they're taking it a lot more um, seriously, and that's good. And that I see promise in that. The second thing I really see promise in, and this is, I don't mean to toot our own horn, so to speak, but we have been, as an institute, we've been very successful in demonstrating not only cyber fortification, but cyber fortifications that lead to lowering energy costs and increasing productivity. And I think the more we can link cybersecurity power with productivity gains, the easier and easier those discussions become. Um, I talked just last week. We had an event where we had a bunch of companies, that aren't members or aren't engaged with the institute yet. Sharing with them some of high level, what our approach is. It turns out one of those companies, I mentioned earlier the C4M facility, the cybersecurity for manufacturing facility we have in San Antonio. It's actually at the Port San Antonio, which is an old Air Force base. There's no water there. So, but this was a robotics company that's literally one parking lot away from our C4M, and the CEO of that company was there. And he and I found each other afterwards, and he had been 2 weeks ago, in Washington D.C., not testifying before Congress, but on a fact-finding discussion, a roundtable discussion with a bunch of his robotics colleagues, and several of the Congress folks asked various versions of, this is very impressive. You've got these machines. It's awesome what they're capable of. How are you making them secure? And to an individual person and an individual company, the answer was, you know, we don't really. We're
Yeah,
we're very focused on making the robot do what we want the robot to do.
sure.
And so, when he realized we were literally, 500 feet away working on these next generation,
Yeah,
approaches, he stuck his arm in the air and said, you and I need to have a discussion. I
yeah.
I need to get you over there. We need to have a talk about how I can do my robot stuff in a
Hmm.
secure fashion. And I
Yeah,
said, his name's Eric. I said, Eric, not a problem. I said, we have secure nodes in San Antonio, in Knoxville, Tennessee, in Idaho Falls, Idaho, in Lafayette, Indiana, in Columbus, Ohio. We have nodes everywhere. I think
sure.
if we've done that, we can figure out how to get across the parking lot to you. So,
Yeah.
we're setting that discussion up right now. And I think part of that's what makes me optimistic is
Yeah.
when people understand and hear our story, they're increasingly getting it, and even more than getting it, they're you can see their eyeballs go up sideways as they're thinking about how can I engage here?
Yeah.
Because I can see I need to, but how do I actually work that out? So, that's where I see goodness.
No, that's great to hear. Great to hear those more of those conversations are taking place. Howard, this has been fantastic. Really appreciate the time. Any parting thoughts you'd like to share with the audience before we sign off here?
Well, it segues off that last question, I think, Jeff. In cyberland, um, there's a lot of vendors selling a lot of stuff. And in general, there's an internal phrase. Some of your audience may have heard it, some won't, but it's called FUD, the FUD approach: fear, uncertainty, and doom. And so you go in, you have a firewall you want to sell, you convince the person you're talking to that FUD is there, it's going to happen, and you need this as a necessary, protection. Again, not making any comments about quality or whether it works or doesn't work. The culture is a FUD culture right now. And, we need to change that FUD culture to one of facts, understanding, and decisions. And those decisions can be very well informed, and that's what they need to be. But we need to get away from, the oh my God, the sky is falling, it's falling directly on me, and this is my answer to that. And we need to get to a place where we're really thinking about what are the facts, how do we understand the physics of what we're thinking about here. Even if you never took a course in physics, we can help you understand how that impacts you without going into any of the math. No calculus, promise. No differential equations, promise. No formal methods, promise. But we can go in and we can help you understand at a at a non-mathematical level, what you need to understand. And then how do you use that information to create informed decisions? Because there is that pathway. And that pathway exists today, and that pathway is going to get better and better, as CyManII and hopefully other organizations or entities, continue to do this. One of the things about the institutes, by the way, is that we are federally funded, but we are not expected to be federally funded forever. So I take that very seriously. And at the end of the day, bluntly, we need to either collaborate with a private or multiple private companies to commercialize the technologies that we've already got, proven out in industrial settings. But we need to do that. We need to do that at a General Motors scale, not at a little, very well funded by multiple standards. But, we need a different scale of deploying the assets that we're currently building. So I think I see a lot of promise in that.
For more information on the work Howard and his colleagues are up to, you can visit him at CyManII.org. That's CyManII.org. I'd also like to thank you for joining us today, and to catch up on past episodes, you can go to manufacturing.net, IEN.com, or MBTmag.com. You can also check Security Breach out wherever you get your podcasts, including Apple, Amazon, and Overcast. And if you have a cybersecurity story or topic that you'd like to have us explore on Security Breach, you can reach me at jeff@IEN.com. For Howard Grimes, I'm Jeff Ranke, and this is Security Breach.